Good morning, dear students. So today we will be studying Science 1, Chapter 1, Laws of Motion. In this chapter, we will be studying the various concepts of motion, acceleration, distance and displacement, Newton's laws of motions and the related equations. Now, let us go to page number 1, Motion of an object. Can you tell? In which of the following examples can you sense motion? How will you explain presence and absence of motion? 1. The flight of a bird. 2. A stationary train. 3. Leaves flying through air. 4. A stone lying on a hill. So here we can see that example 1 and 3 there is presence of motion. So, we see the motion of several objects every day. Sometimes we cannot see the motion of an object directly, as in the case of breeze. You can list other examples of motion besides those given here. Think about it. You are traveling in a bus. Is the person sitting next to you in motion? What do you take into consideration to decide if an object is in motion or not? So let's answer the first question. The person sitting in the bus is at rest if I am the observer and is in motion for an observer outside the bus. The observer is considered to decide if an object is moving or not. Now the second question. How will you decide if the object is moving or not? Here, displacement, or if the thing leaves its original place, we say that the object is moving. You have learned that motion is a relative concept. If the position of an object is changing with respect to its surroundings, then it is said to be in motion. Otherwise, it is said to be at rest. Now let's see the concept of displacement and distance. Let's try this. Measure the distance between points A and B in different ways as shown in figure 1.1a. So here you can see the distance can be measured differently. If you go across this curve, you can measure the distance from A to B separately. But if you go towards the dotted line, it is a different length. Now, distance may be different lengths depending on the path taken. Now, second question. Now measure the distance along the dotted line. Which distance is correct according to you and why? So, it depends upon the path taken. From A to B is the shortest distance. The dotted line shows the shortest distance. Now, let us see about the next figure 1.1b. You can see there A. Sheetal first went to Sangeeta's house on her way to school. So 1.1b figure. B. Prashant went straight from home to school. Both are walking with the same speed. Who will take less time to reach the school and why? So here Prashant will take less time as it is the shortest path. In the above example, is there a difference between the actual distance and the distance travelled, and what is it? So we will be seeing about it. So here you have seen that path A, Sheetal goes 500 meters to Sangeeta's house, and then from path B 1200 meters to school. Whereas Prashant goes directly from his house to school 1300 meters. Now in this slide you can see the two figures there. The first figure, you can see it's a curved path, distance purple color, one part taken, and displacement is the green dotted line. It is the shortest distance. In the second figure, in the circle, you can see A to B is the displacement. It is the shortest distance. Directly one person can move from A to B, whereas if you go along the circumference, half semicircle, it is the longest route or the distance travelled. Okay. Now in the next slide, you will see further about displacement and distance. Now, let us differentiate between distance and displacement. So, first let us see the definition. The complete length of the path between any two points is called as a distance. Displacement is the direct length between any two points when measured along the minimum path between them. Denotation or how is it denoted? Distance is denoted by the letter D, small letter d, and displacement by small letter s. Then direction consideration. To calculate distance, direction is not considered, whereas to calculate displacement, direction is taken into consideration. Fourth, quantity. Distance is a scalar quantity as it only depends upon the magnitude and not the direction. Displacement is a vector quantity as it depends upon both the magnitude and direction. Route information. Distance gives the detailed route information that is followed while traveling from one point to another. As displacement refers to the shortest path, it does not give complete information of the route. Formula: speed into time. Distance is equal to speed into time. Displacement is equal to velocity into time. Possible values: distance can have only positive values, whereas displacement can be positive, negative, and even zero. Indication: distance is not indicated with an arrow, whereas displacement is always indicated with an arrow. Measurement in non-straight path. Distance can be measured along a non-straight path. Displacement can only be measured along a straight path. Path dependence. Distance depends upon the path, that is, changes according to the path taken, and displacement does not depend upon the path and it only depends upon the initial and the final position of the body. Now let us go to the next slide. So here we can see that distance is the length of the actual path travelled by an object in motion while going from one point to another, whereas displacement is the minimum distance between the starting and the finishing points. So you can mark this definition. You have to learn this. Even I have given you in the differentiating columns. Now let us go to use your brain power. Every morning, Swarali walks round the edge of a circular field having a radius of 100 meters as shown in figure 1.2a. If she starts from point A and takes one round, how much distance has she walked and what is her displacement? Her displacement will be 0 as it is the shortest distance. She is coming back to her original place, so displacement is 0. Now let us calculate the distance. So it is a circle. So circumference is equal to 2 pi r. Circumference is given to be 628 meters. So circumference is equal to 2 into 3.14, the value of pi, into 100. R is 100. So that is equal to 628 meters. Second question here. If a car starts from P, goes to point Q, see figure 1.2b, and then returns to point P, how much distance has it travelled and what is its displacement? So here, since the car is going from P to Q and Q to P again, displacement is 0. Now let us calculate the distance. From P to Q, the distance is 360 meters, and from Q to P back again is 360 meters. So total comes to 720 meters. Now, I hope you have understood this questions here. Now, even if the displacement of an object is 0, the actual distance traversed by it, traversed means travelled by it, may not be 0. Now, I hope you have understood the concept of distance and displacement very well. Now, let us see, can you recall what are vectors and scalars? So here, scalars have only magnitude. For example, distance, time and mass. Vectors have magnitude and direction. For example, displacement, velocity and momentum. In the differences between distance and displacement also it's given there. It's a scalar quantity and it's a vector quantity. So you can refer to that also. Second question, which of the quantities distance, speed, velocity, time and displacement are scalars and which are vectors? So here distance is a scalar quantity, speed a scalar quantity, velocity is a vector quantity, time scalar quantity and displacement vector quantity. Fine. Now I hope you have understood this well. Now let us continue with speed and velocity. Now the formula for speed, calculating speed, is total distance traveled upon time required. So here let's see the definition of velocity here. The distance traveled in a particular direction by an object in unit time is called as velocity. You can mark it and you have to learn it. Here unit time can be 1 second, 1 minute, 1 hour, etc. If larger units are used, 1 year can also be used as a unit of time. Here one more definition of velocity here. The displacement that occurs in unit time is called as velocity. The formula to calculate velocity is velocity is equal to displacement upon time. Always remember the units of speed and velocity are the same. The SI system, that is international system, SI is international system. The unit is meters per second, while in CGS system it is centimeters per second. CGS means centimeter, gram and seconds. Second, speed is related to distance while velocity is related to displacement. Third, if the motion is along a straight line, the values of speed and velocity are the same. Otherwise, they can be different. So, velocity is the displacement that occurs in unit time. Now, let us see the pictures here given. Here you can see speed versus velocity. For the first car, simply speed is the distance travelled per second. This car's speed is 20 meters per second. Second car, velocity is the distance travelled per second in a specific direction. Direction is important. So, speed of 20 meters per second to the right. Okay, now let us go to the next slide where we will see the difference between speed and velocity. So first, definition. Velocity can be defined as the rate at which the object changes position in a certain direction. Speed, the rate at which an object covers a certain distance, is known as speed. Second, type of quantity. Velocity, vector quantity, speed, scalar quantity. Magnitude, velocity can be 0, negative or positive. Speed can never be negative or 0. Change in direction. The velocity of an object changes with the change in direction. Therefore, the object must follow one direction. The average speed will continue to count even if the object changes the direction. Interrelation. An object may possess different velocities but the same speed. Speed may or may not be equal in velocity. Unit, SI unit, velocity is measured in meters per second. Speed is also measured in meters per second. Equation of velocity is delta x upon delta t, where it is the average velocity. Delta t is the time of arrival and delta x is the displacement. V is equal to d upon t, where V is the average speed, t is the time taken to travel the distance and d is the distance travelled. Example, a train moving towards south with an average speed of 50 km per hour will have a velocity of 50 km per hour north. An object going straight in a particular direction is considered to have velocity. A sports bike traveling at 15 meters per second would go from 0 meters per second to 30 meters per second before reaching 50 meters per second and could even reach 70 meters per second. However, the average speed will be the speed of the bike. Okay. Now let us go to the next slide. In the first example on page 1, the straight line distance between the houses of Sheetal and Sangeeta is 500 meters, and that between Sangeeta's house and the school is 1200 meters. Also, the straight line distance between Sheetal's house and the school is 1300 meters. Suppose Sheetal takes 5 minutes to reach Sangeeta's house and then 24 minutes to reach the school from there. Then Sheetal's speed along path A is equal to distance upon time, that is equal to 500 meters upon 5 minutes, that is equal to 100 meters per minute. Sheetal's speed along path B is equal to distance upon time, that is equal to 1200 meters upon 24 minutes, that is equal to 50 meters per minute. Sheetal's average speed is equal to total distance upon total time. So 1700 meters upon 29 minutes is equal to 58.6 meters per minute. Now Sheetal's velocity is equal to displacement upon time. Displacement is the shortest distance, that is 1300 meters upon 29 minutes. So Sheetal's velocity is 44.83 meters per minute. So I hope you have followed the difference between speed and velocity. Now let us continue with the effect of speed and direction on velocity. Sachin is traveling on a motorbike. Explain what will happen in the following events during Sachin's ride. See figure 1.3. First case, what will be the effect on the velocity of the motorcycle if its speed increases or decreases, but its direction remains unchanged? Second, in case of a turning on the road, will the velocity and speed be the same? If Sachin changes the direction of motorcycle, keeping its speed constant, what will be the effect on the velocity? Third, if on a turning, Sachin changes the direction as well as the speed of the motorcycle, what will be the effect on its velocity? So it is clear from the above that velocity depends on speed as well as direction, and that velocity changes by 1. Changing the speed while keeping the direction same. 2. Changing the direction while keeping the speed same. 3. Changing the speed as well as the direction. So let us see in this slide. Here the first car 1 is traveling with 65 kilometers per hour, that is 27.1 meters traveled before the brakes are fully applied. Car number 2, 60 kilometers per hour, 25 meters traveled before the brakes are fully applied. So it's going in a straight direction, in one direction only. The speed is changed. Now the second figure, you can see the direction is also changed. Third figure, car in motion makes a left hand turn. So the speed and the direction both are changed. So in this examples we can see that the effect of velocity depends on direction as well as the speed. So velocity is affected by speed as well as direction. Now always remember, the first scientist to measure speed as a distance upon time was Galileo. The speed of sound in dry air is 343.2 meters per second, while the speed of light is about 3 into 10 raised to 8 meters per second. The speed of revolution of the earth around the sun is about 29,770 meters per second.